It's almost Christmas, and I just realized that I still haven't fixed the Grinch I bought for Christmas last year. In 1986, IBM did something very strange. Just 6 months before launching the all-new Personal System 2, they made this 5162 XT Model 286 for a few months. In a case similar but not identical to the XT and a 6 MHz 286 with 0 wait states. At the time their flagship was the 5170 AT, a 286 system running at 8 MHz with 1 wait state. So even at 6 MHz, the 5162 is only a few percent slower than the AT. Unfortunately, this IBM is a real Grinch and blew out the magic smoke from the display last Christmas. If that wasn't bad enough, it also has a weird fault that prevents the system from completing posts. We have repaired the display in another video. It had no less than 4 faulty components, 1 blown up safety cap, 1 completely dead electrolytic cap, and 2 bad resistors. Okay, let's get inside this IBM. See if we can figure this out. You can tell that we haven't worked on this project for a while, because this machine is fully restored, and yet we have some cobweb in here. So apparently we have had a visitor. Okay, we've got some loose cables, and some EPROMs, and some screws. So this machine is still partially disassembled. So let's get that motherboard out. Yeah, now I remember, I think we have a shorted tantalum on this card. Because with that card installed, the power supply would shut down. But that is the least of our problems. Because this board has a really tricky RAM issue. The RAM has been tested and replaced just to be sure. So we know the RAM is good. And yet we're getting a RAM error. So to be honest, I have no idea what the fault is. But we're just gonna have to figure it out. Okay, and the motherboard is free. By the way, this machine is in a remarkable condition, so it has been really well preserved. One interesting thing about this machine is that it has 466 written on the motherboard. And down in the corner here, it has a really fancy badge with a matching number. So for whatever reason, IBM wanted to match this case with this board with a really nice and shiny badge. It's a thick and shiny aluminium badge, similar to the badge at the back here. I just realized I haven't even washed this case, because there is some dust back here, and some more dust down here. Dust that would normally come off if you wash the case. So this IBM actually came this clean, which is rather unusual for a machine from 1986. Yeah, I can clearly see some dust back here too, so I really should wash it. Well, I pulled out my scope and turned the machine on, but now I'm getting nothing on the screen. Oh no, this project just went from bad to worse. This board is now completely dead. The graphics card is tested 5 minutes ago, so that is not our issue. Well, I guess we should try with the post card. Actually, I'm not sure if this is a bad thing, because if we had a marginal chip before, and if it's now completely dead, it may actually be easier to find. Okay, and it's not posting at all. But we've got voltages, and we've got a clock. Let's check if we have a ready signal. Turn the machine off. Actually, I'm not sure we do. The LED for ready didn't flash. No, it doesn't. The reset LED to the left here should flash once. And the second LED from the right here should light up when the system is getting a ready signal. Let's turn the machine on again. The reset line flashed once, so that's okay. But the ready LED doesn't light up. So it seems to me that whatever chip was marginal before, it's probably dead now. Before we start poking around with the scope, let's do a quick test with the original power supply. No, there was nothing wrong with that power supply. We still don't have a ready signal. By the way, we have done a whole bunch of troubleshooting with this board in a previous video. So that is why there are a bunch of markings on some of the chips here. The ready pin isn't easily accessible on the 286, but I checked in the schematics and it's connected to pin 4 on U79. This was actually one of the suspects in our previous attempt. If I remember correctly, we had some connection issues. So I have soldered this chip to sockets and then put it back with an extra socket into the board. So this could potentially be causing our issue. Oh, it goes high. So we do have a ready signal, but it's not reaching the ISA slot. 4.6 volts. That is perfectly good logic level. Well, we know that U79 here is an Intel 82284, and that is the clock generator. But apparently it also contains logic to supply ready to the CPU. So this is definitely our suspect. I don't remember why this was a suspect in our previous attempt, but apparently it is again. Okay, I found a freshly tested chip. So let's just swap it and see what happens. Let's turn the power on and check that LED. No, still doesn't light up. So it wasn't that easy, unfortunately. Okay, let's start poking around with the scope and see what we will find. I installed Mathco just to get better access to the data pins. So let's just pick one and see what's going on here. Absolutely nothing apparently. I'll check a few pins. Yeah, they're just going up 1.5 volts. This one is high at almost 5 volts. So the post card is correct. We don't have any activity on this board. So let's check the main crystal next. And this guy is a 12 MHz crystal. That looks fine. It looks to be very stable at 12 MHz. Well, the post card is showing that we have a reset. But let's check it anyways, close to the CPU. And the reset pin on the 286 is going to pin 6 on U47 here. And that's a 74 ALS00. So let's turn the machine on and see what happens. It went high and then low again. So that seems to be working, as indicated by the postcard. Okay, so this is weird. That CPU is getting a reset, clock and ready, and yet we're not getting any data. Well, I suppose it could be the CPU. So we might as well start by replacing it and see what happens. This is not the original 286 that came on this machine, by the way. This guy is good for 10 MHz. Well, since we have the CPU out, we might as well check a few things as close to the CPU as possible, directly in the socket. So pin 31 here should be the clock. And there we have it. Perfect 12 MHz. And pin 32 next to it is our reset. So let's turn the machine on. It goes high and then back down again. I almost forgot to check if we have power at pin 30. And we do. 4.7 volts. Okay, well in that case, let's do a test with a known good CPU. Let's flip that switch. No, it still doesn't post. So that 286 was probably good. Well, one thing that could cause this that is easy to test is bad BIOS. So let's remove these diagnostic ROMs and install something else. Okay, I found the original BIOS chips in that bag I had left inside the machine. So let's install these guys and see what happens. Oh, it's posting. Yes, progress. So one of these stupid EEPROMs is bad, but we still have the original fault. So we haven't actually fixed anything yet. Well, I did leave them with the window uncovered, but they were inside the machine with the lid on. So they have been stored in complete darkness. But who knows? These are some reused chips from eBay, so you never know how long they last. Okay, so this error here is telling us that we have a fault in the first 64K of RAM. And same thing with these diagnostic ROMs. Well, until they stopped working. And the same thing with the postcard. So the first 64K of RAM resides in these two SIMs here. This board has some more RAM here, but this RAM has been disabled and is not needed for this test. Now the big issue here is that these RAM sticks are tested. I even swapped them for known good RAM, but I'm still getting the same error. So something on this motherboard thinks that these RAM chips are bad. Okay, so let's poke around next at the SIMs here and see if we can find something interesting. By the way, I added an anti-glare filter to the scope and it does work, but I also noticed that it's a bit hard to read on camera, so I'll probably remove it. Okay, so let's start with the VCC pin and see if these RAM chips have power. 4.7 volts. That's good enough. And on pin 27 we've got the RAS. Well, that looks pretty normal too. And on pin 2 we've got CAS. Yeah, I'd say that looks pretty normal too. And of course I can't say if they are perfect or not. This is just an indication and could in best case give us a clue. Okay, address line 0 at pin 4. Looks good too. Address line 1, 2, 3. I'll just check them all and skip ahead here. And unfortunately this is the last address line and it looks good too. So no clues from the SIMs. Okay, so everything seems to be working. And yet it's not. So next I'm thinking maybe this is some kind of weird timing issue. We have already checked the main crystal. So let's check this guy here next. And it's marked 14318 something. Okay, let's see what it measures. 14.32. So that crystal is probably good too. Okay, next up we have this tiny little guy here. Y2. I had to look it up in the schematics because I can't quite read what it actually says on top here. And according to the schematics, it's 32.7 something hertz. So let's see if we can measure this guy. Not so easy. This thing is ridiculously tiny. I just realized I wasn't recording the display. So let me show you what we've got here. Okay, and this guy here measures 16.6 kilohertz. Let me double check the schematics. Well, the schematics actually say the double, 32 point something kilohertz. I'm not familiar with the circuitry here, but 16 is not 32. So that's definitely a suspect. Okay, I checked my stash and apparently I've got plenty of these. And that is because apparently these are the same crystals that we use to hack Dallas chips. So I always keep a stash of those. I added some fresh solder to those tiny leads. I'll use my desoldering needles to make sure they are free. I think they are. Now let's see if we can bend those leads up. Yes, I think this is working. Sort of. That one is out. They are really tiny and soft. Otherwise this wouldn't have worked. Bit tricky to get on camera. But both leads are now pointing up and are not making contact with the through holes. My replacement crystal is even smaller. So let's bend those leads out so they will fit the through holes. And then I'm just going to solder it from this side of the board. That should be sufficient. Like so. Really ugly. I can't see why this shouldn't work. Okay, fingers crossed. No, same error. That board couldn't care less about that crystal. But this is a bit strange. Why was it measuring 16 instead of 32? And yet, didn't make any difference. Huh. Okay, I did some reading and checking, and apparently this crystal here is for the real-time clock chip up here. And apparently it's quite similar to the good old Dallas chip, the DS12-8087. So no wonder they are using the same crystal. And since I'm getting some really weird readings here with both crystals, this is our main suspect now. Unfortunately, I don't have a spare chip, but I found something interesting online in this application note. Systems that have been designed to use this chip can be modified to operate with the Dallas DS12-8087. Okay, so let's add some fresh solder to all the pins. Oh crap! Every single pin is bent. That is just pure evil. Why would someone do this? Okay, let's bring out the desoldering gun. I'll melt the solder first, and then bend the pin up before I remove the solder. Yeah, I think this is working. So I'll desolder all the pins and skip ahead here. Well, I mean, bending one or two of the pins is quite understandable, but bending every single pin, that's just evil. I'll use the desoldering needles to check if all the pins are loose. And they were. So here's our chip. So now we can go ahead and replace that chip with a socket. That'll be nice and solder all the pins without bending them. Not that this socket is ever going to be replaced again. I'll wash this board when it's finished and working. And for now I'm just going to clean up the flux. Well, I don't have a proper Dallas chip where the battery is still good. But thanks to the sponsor of this video, PCB we've got these replacement boards. And speaking of PCB they're now running a big Christmas sale. So if you need some PCBs, check out PCBWay.com and give them a try. Aside from making excellent PCBs, they also do PCB assembly, CNC machining, 3D printing, sheet metal fabrication, and injection molding. Thank you PCBWay for supporting this channel. Now let's see if this chip is similar enough to the original clock chip. Okay, apparently there isn't quite room enough for the graphics card on top of the module. So if this works, I would probably go for a hacked original chip instead, because it sits much lower. And you would obviously have to replace the original battery. But for this test, I'm just going to use a different slot. Okay, fingers crossed. Reset flashed, and the postcard is stuck at FF. Oh crap, I was really hoping this would work. Okay, I went through my stuff and I found something similar to the original chip. So the original chip is 146818AP, and the chip I found, MC146818P. I did a Google search of course, but I can't find a difference between these two. So let's just try it out and see what happens. Okay, chip installed. So now I'm thinking maybe this module here may require some additional changes to the motherboard to work. Okay, fingers crossed. Okay, reset flashed. The LED for ready still didn't light up. We're stuck at 3F. And the chip is not getting hot. Let's do a test with the original chip again. Oh no! We're back at square one. The board isn't posting anymore. We don't have any errors on the screen. Something else just died on this board. Oh, come on. What a Grinch. We better check that power supply and make sure it's not killing our chips. 4.9. 4.9. 4.9. Minus 4.8. minus 11.6. 12.5, that is slightly too high, but not enough to kill our chips. 4.9 and 4.5. So no, the power supply seems okay. Let's check the temperatures and see if anything is getting suspiciously hot. CPU is 50, Mathco 50, 37. EPROMs are completely cold. So did these EPROMs die too? No, everything seems okay. But I was expecting these EPROMs to at least warm up. And they're not. We better check. Let's pull these guys off the board. And try with something else. Okay, I found a set with an Army BIOS that works in this board. Okay, let's see what happens now. It's beeping an error code. I think that's 3 short beeps. But we're still not getting anything on the screen. And the machine is stuck at FF. So I don't think it really matters what that beep code is, but I'll check anyways. Yeah, that was the same error as we had before. For base 64K of RAM. And the postcard actually changed to 02. But we're still not getting anything on the screen. Wow, what a Grinch. Okay, I did some boring tests here off camera. And then this happened. While I was checking the ready pin near the CPU. So this Grinch is definitely worse off than when we started. So I grabbed the 5170 and tested the graphics card and the diagnostic ROMs we started off with, and they are indeed bad. I also checked the Army BIOS we tried to use, and it works perfectly fine. And then I tried all 3 real-time clock chips, and all 3 chips were working in a 5170. I didn't do a thorough test, but the 5170 does post with all 3 chips, so they are at least partially compatible. So that means that the Grinch has one more fault, and we are worse off than when we started. Let's do a reboot and see what happens. Okay. At least it seems to be consistent. That is always good. I also did some tests on the board. The clock is still working and the reset line. But when I check the ready pin, this is what I'm getting. It jumps up and then down again. So that is the clue we have for the next attempt. Well, it is the Grinch after all, so I guess he is supposed to steal my Christmas. I hope you guys are having better luck with your Christmas projects. And that was a good time to check out this video. I will end by saying thank you to my patrons, I appreciate your support. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. I wish you all a Merry Christmas, and I'll see you again next week.